Hello all, I am Ms. Sugandhi Gupta and topic that I have chosen today for discussion is time value of money. Before we move on to the topic, I would like to ask you a simple question. Out of the given options, what will you choose? You have won a prize and you can redeem that 10,000 rupees today, or another option is that you can redeem the same price after 5 years. Have you decided? I think you all might have chosen option A, which is logically the correct answer, that you should redeem your prize immediately rather than waiting for 5 years to redeem it. Now, knowingly or unknowingly, you all have used the concept called time value of money. So let us theoretically look at what is the concept of time value of money. Now, when I say time value of money, there are two values attached to money. One being mathematical value, another being economical or financial value. So, when I refer to the concept of time value of money, it refers to the economical value or the financial value of the money and not the mathematical value of the money. To differentiate between the two, I would like to give you an example. In the previous slide, you all have chosen option A over option B. The reason being, if you see mathematically, both are rupees 10,000 today or rupees 10,000 after 5 years. So mathematically, even if they both have same values, economical value will change over a period of time. This can be elaborated with the help of an example. Just try to recollect what all things you could have done in rupees 10 when you were a child. Now, for example, you could have purchased one pencil, eraser, sharpener, and scale with same rupees 10 when you were a child. But now, if you go with same rupees 10, the mathematical value being same, the economical value has reduced because now you can buy only maybe a pencil and an eraser or a scale or a sharpener with the rupees 10 note. So when we are discussing in finance, we are talking about the economical or the financial value of the money. The time value of money concept says a sum of money which is owned now will have greater value than the same sum of money if you hold it in the future, like in the case of lottery. Now, why this is so? Because money itself has some earning potential. If you invest it wisely, you can get good returns on the money. Now, this small concept of time value of money is one of the most basic fundamental concept which is applied across the banking sector, financial markets, any kind of investments, any kind of major purchasing done by the corporates. And hence, it becomes very important to study this particular concept. Now, why this time value of money concept per se exists? So it exists because there is risk and uncertainty. It means that the default risk, you are not sure whether after 5 years the person will still give you the money or not. So the default risk is extremely high. You don't know whether the associated cash flows will take place in the future or not because future is uncertain. And that is the reason why having money now is better than later. The second point is inflation. As I've already told you, the money, with rupees 10 you can do now, maybe the same things or even lesser things you can do after 5 years. Just for with an example of rupee 10, it can be made clear. Consumption preference. The main idea is why should you not consume that rupees 100, 10,000 or whatever is your saving today? Because bank says that if you save this rupees 100 today, tomorrow you will get maybe 110 rupees. That's the incentive which motivates people to avoid present consumption and go for the future consumption. So that is one of the reason why time value of money needs to be considered. Another one is investment opportunities. There can be multiple investment opportunities where if invested properly, you can get good amount of returns on the same money. So maybe money that you keep in your pocket will get reduced in its value because of inflation. But if invested wisely, the same money can work for you in a better way. This brings us to the two major pillars of time value of money. That is, how the time value of money will get affected. One, it will get affected by the time frame which we are looking at. So, are we looking at 1 year return, 2 year return, 10-year return? That will have a major impact on the valuations. Another thing that will have an impact on valuation is the required rate of return or the interest rate that I'm expecting to get on my investment. The higher the interest rate that I'm expecting, uh, the more, I mean, the higher the expectations in interest rate, the more it will affect the valuations. Now, we let us look at calculation of interest, basically how time value of money is calculated. So we all know that there are two types of interest which exist. One is simple interest, the another one being compound interest. So let me quickly revise for you what is simple interest and what is compound interest. Here I'm assuming some Mr. A has deposited rupees 10,000 in bank on a simple interest basis for a period of 3 years. And the rate of interest that the bank is ready to pay is around 8%. So what happens in this situation? This is my timeline. So when I'm saying 0, it means it is day to day, today's date. Okay. Year 1, year 2, year 3. So after 1 year, after 2 years, and after 3 years. That's how we will interpret this line. Now what happens is, today Mr. A goes and deposits money into the bank. And after 1 year, he expects certain kind of interest to be calculated. So interest will be calculated on simple interest basis, and hence 10,000 rupees 10,000 at the rate of 8% will fetch him an interest of rupees 800. After one more year, that is in the second year, again he will get an interest of 800, and in the third year again he gets an interest of rupees 800. It means at the end of each year, the person is getting an interest on the principal amount itself. So he is getting an interest on the principal amount. He is not getting any interest on the interest that he has earned. Maybe at maturity he will get all these 800 rupees together, that is 2400, along with this 10,000. So that's how simple interest is calculated, and the formula is principal into number of years into the rate of interest. Moving towards the next part. Now, there are two values. When I say time value of money, either you will be asked to calculate future value or you will be asked to calculate the present value. In this particular presentation, I will cover only the future value part. Let us look at what is future value now. So, future value is the value of present cash flow after certain period of time. If I ask you, so the process of calculating future value is called as compounding. It is called as compounding. Now, if I tell you that, certain amount of money has been deposited into the bank at a particular rate of interest, But how much will I get at maturity? The answer to this question, how much will you receive at maturity, will be given by calculating the future value of the money. Now, future value, as I said, means compounding value or future value. Now, we will be studying all these things in this PPT. The first one being single cash flow. Now, when I say single cash flow, it means I will deposit money at a particular date only. In the sense, today I deposit the money and at maturity I go and get back the money. When I say it is a series of cash flow, it means I'm depositing money multiple times in a particular investment. To make the point clear, single cash flow can be considered like a fixed deposit. You go, you invest your lump sum amount of money into the bank, and you wait till maturity, get your money. Whereas series of cash flows, it means it is like a recurring deposit investment being made. So you make the investment again and again after a particular period of time. Then these can be divided into annuity and annuity due. But these topics I will take as and when the presentation progresses. So let us in detail look at future value of single cash flows. I'm continuing with the same example. Mr. A deposits 10,000 for a period of 3 years at the rate of 8%. Now, one thing to be noted is I have covered simple interest part, but I have not covered compound interest part, which I will cover it now. I'm saying this money that he has deposited is getting compounded on an annual basis. Now, what difference does it make from the investment point of view? Let us have a look at it. This is again the same time series. So today I'm standing here on 0, after 1 year, after 2 years, and after 3 years. He has deposited 10,000 rupees into the bank today. After 1 year, Mr. A will receive rupees 800 as his interest. Now, so the amount that he has after 1 year would be 10,000 plus this interest of 800, that is 10,800. Now after the second year, that is from first year to second year again, the interest should be calculated. So now the interest will be calculated on this 10,800. So you are basically calculating interest on the principal amount, and you are also calculating interest on the interest that you have received in the first year. So it is 8% of 10,800, that is 864. Now, at the end of second year, if you ask me what is the value of his investment, so these both interest will get added to the principal amount, and now the investment value is 11,664. In the third year, now the interest will be calculated on this particular amount, and that would be 933. Now, what has changed in this process? In the simple interest, always the interest is calculated on the basis of the initial investment that you have done. That is, in this case, 10,000. But in case of compound interest, that is future value of the cash flows, if we have to calculate, interest will be calculated not only on the principal amount, but also on the interest that you earn after each year. Now, if you have to keep continuing this, if you have to keep doing this way, it might take very long, and hence a formula has been developed. Let us look at the formula. This is the formula. So the formula says present value. This is the same compound interest formula that you have studied in maybe financial mathematics or quantitative techniques. Now, this particular formula, present value. we call generally in financial mathematics as principal amount. It is the present value of investment that I'm doing. In my case, it is 10,000. 1 plus R by M. R is the rate of interest per annum. N is the duration for which you are keeping the money. And M, this is a very important factor. M is the frequency within which, within a year, money getting compounded. So it's the frequency of compounding within the year. Now, in first case, we have considered that the compounding is taking place annually. When I'm saying that, it means the interest will be calculated only after 12 months. That's what it means. Interest will not be paid to you, but it will be calculated and added into the principal amount after every 1 year. So if we substitute all these values into the formula, we get something like this. The future value is summation of all interest plus the principal amount, which is this. Or you substitute present value 10,000 plus 1 plus rate of interest divided by compounding frequency. In this case, it is 1 raised to 3 into 1. If you calculate using this formula, also you will get the same value. Now, so now this is the case where compounding happens annually, but sometimes compounding can also happen at much faster rate. So maybe twice in a year, 4 times in a year, 5 times in a year, or maybe 12 times in a year. So when the rate of compounding increases, let us look at what happens to our investment. This is same. I'm doing one-time lump sum investment. Here the compounding is taking place on a semi-annually basis. That is, when I say semi-annually, it means twice in a year. It will get compounded within a period of 6 months. So the same number line is there, but I have added 6 months component into it. Let us have a look at what happens to the case. Same case, 10,000 rupees has been deposited and 8% interest for a period of 3 years, and compounding being done semi-annually. This is very, very important. Now, what happens in a semi-annual cases, if you look at it from 0 to 6 months, once the compounding will take place. And from 6 months to 1 year, second compounding will take place. It means in same span of 1 year, 2 times the compounding will take place. Once after 6 months, every 6 months. So now Mr. A, on 0th date, that is today, he has deposited 10,000 rupees. Now when it is at the end of 6 months, he will get only 6 months interest. So this interest is for 12 months. It will get divided into half, that is 4% he will get. So if 10,000, pay 4%, if you calculate, you will get 400 rupees interest. This interest he has received at the end of 6 months. Now what happens is, at the end of 6 months, if you ask me what is his investment value, it has become 10,000 plus 400. So the interest that is to be calculated at the year end will be calculated on 10,400, which is 416. Now, at the end of 1 year, again his value of investment, if you ask, it will be initial 10,000 plus these both interest, which comes out to be 10,816. Now the next year's interest, that is from 12 months till 18 months, the interest will be calculated on this amount and the cycle will keep on going. So again, it will be 2 cycles in a year. This interest has been calculated on 10,816. If you add this value to 432, you get approximately this. Now the next interest will be calculated like that. So it is calculated every 6 months. Now, if you have to keep doing this, it will again be a time consuming process. Hence, the formula has been developed. Let us look at the formula. What changes? The formula between this present future value and the previous one remains the same. Only one important factor, this is M. This particular factor here and here, it will get changed. Now let us have a look at it. The face value or the initial value that you have invested, the present value that you have invested does not change. It remains rupees 10,000. The rate of interest is 8% for 1 year, but in a year it is getting compounded twice. So the frequency of compounding, this is very important, frequency of compounding within the year is 2 times. Hence, as the formula says, divide by M, I'm dividing it by 2. It will automatically convert the interest into 6 monthly basis, that is 4%. Then the next part are these two parts. I am keeping my investment for a period of 3 years. So that is there as it is. But in these 3 years, it will get multiplied by 2 because it will get compounded 6 times. As we have seen, within a year it is getting compounded twice. So these are 2 times. Here these are 4 times, and the next one cycle would be 6 times. So it will get compounded 6 times in a year, and the value will come out to be this. This brings me to a very important concept called effective rate of return. Now, what is this effective rate of return? See, when I'm saying I have promised that I will give you a return of 8%. In the sense, the bank is giving you a return of 8% on the deposit. Now, when this happens and the compounding is taking place on semi-annual basis or quarterly basis, basically you might get a little more return as compared to 8%. Let us see how. So what is effective rate of return? It tries to determine what is the impact of compounding on the interest rate. So whether because of compounding my interest rates will increase or it will decrease. Whether I'll get more benefit or I'll not get more benefit. Like in the previous example, you have a semi-annual compounding. So what is happening is within 1 year, see, when the compounding was happening on an annual basis, you got an interest of 800 rupees per year. But when the compounding is happening on a semi-annual basis, you get a return of 816 per year. It means you have got 16 rupees extra over 10 on 10,000 rupees. So if you have to basically calculate an effective rate of interest, it would be total return after 1 year. So the value is 10,000 plus 816 divided by the initial investment. If you do this, you get a return of 8.16. It means even if the bank has promised you a return of 8%, you are basically getting a return of 8.16%. Now let us look at the formula for it. Effective rate of return is 1 plus r by m raised to m minus 1. If I substitute in the formula, it means 1 plus annual rate of return, which is 8%, divided by 2, because the frequency of compounding is 2 within a year, raised to again m, which is my frequency of compounding, 2 minus 1. If you solve this particular equation, you will again get an answer of 8.16. These are few of the cases in single cash flows. Now let us look at multiple cash flows. So face value of a series of cash flow we are trying to calculate, future value, sorry. future value of a series of cash flow we want to calculate, and that too of equal amount or annuity. Now, when I say this, it means that I have deposited a particular amount of money multiple times to in a particular bank or any investment which is there. So maybe like a recurring deposit every month or every year, I might have invested some say 5,000, 6,000 rupees, but it is a recurring nature thing for a particular period of time. That will be called as annuity. Now, now I am taking an example. I'm changing the example, which says, suppose Mr. A deposits 1,000 rupees per year, 1,000 rupees per year at the end of the year. This is extremely important. He is investing the money at the end of the year at 5% per annum, and that too for 5 years. It means Mr. A will deposit rupees 1,000 every year for the next 5 years, and this money will get deposited into the bank at the rate of 5% per annum. What will be its maturity value? So let us have a look at how we calculate this. So again, this is the time series. Now I've taken, instead of 3 years, I've taken 5 years because my deposit says it's for 5 years. So 0, 1, 2, 3, 4, 5. Now understand, when Mr. A deposits his first installment, this is today, he is depositing at the end of first year. So he is depositing here. He is not depositing money here. Okay, that's the first thing. Now, this 1,000 rupees which is there, which he has deposited in the first year, it will remain with the bank for 1 year, 2 years, 3 years, and 4 years. And hence, if you see, it will be compounded for 4 times, right? So what is happening? The first installment that Mr. A pays remains in the bank for a period of 4 years, because from 5th year onwards, he will start withdrawing the money. Okay. So first year, the installment remains with the bank for a period of 4 years. Then at the end of first year, at the end of second year, he goes and deposits the money again. What happens? This 1,000 rupees will remain with the bank for a period of 1, 2, and 3 years. And hence the compounding has been done thrice. The value is written here. Third year, it remains only for 2 years, year 1 and year 2. So that's why compounding is done twice. Fourth year will remain only once, hence compounding is done once. And fifth year, the moment he deposits, it's time for maturity, he will withdraw the money, and hence no compounding has been done. Now, if you carefully look at all these cash flows, you will understand one thing, that it's a little tedious process to sit and calculate one by one for each of the year. The main thing to be noted here is, since the deposits have been done at the end of the year, that's why the compounding is not taking for 5 years, even if the person has paid for 5 years, but he has kept money only for a period of 4 years with the bank, and hence only 4 times compounding has been done. So as I said, once the year 1 gets over, at the end of first year, he has paid the money, so it is there for second year, third year, fourth year, and fifth year. Now, this is how the calculation is done if it is done manually one by one. But again, a small formula has been developed. Let us look at the formula. So whenever the term annuity, only the term annuity has been used, it is understood that it is an ordinary annuity. When I say ordinary annuity, it also implies that the amount has been paid at the end of the year. So in question, if they say calculate annuity, it is understood that they are asking ordinary annuity. Now, this particular formula is there. So, ordinary annuity, if I invest, my amount was 1,000 rupees. So, this A is what is the present value of cash flows that is happening. So, it is 1,000 in my case. The rate of return R is 0.05 raised to n. One sign has to be there here. Raised to n, which in this case is 5 years minus 1 upon r. That is again the return. So you have to be very careful while solving this. You have to first open the round bracket. So 1 plus 0.05 raised to 5 you will do. Then you will subtract 1, multiply it with 1,000 and then divide it by 0.05. You will get this particular value. So it says that the future value of investment will remain this. If you compare in the diagram this value and the value that we have calculated using the formula is the same. So this is the ordinary annuity. Moving towards annuity due. Annuity due is a concept wherein you pay the money at the beginning of the year. So if the question says calculate annuity due, it is understood that the money that you're making or the investment that you're making is done at the beginning of the year. It means it starts from today. Okay. Now suppose again Mr. A deposits 1,000 rupees per year at the beginning of the year. At the beginning of the year is very important because it implies that you need to calculate annuity due at the rate of 5% per annum for 5 years. It means he will deposit rupees 1,000 for a period of 5 years at the rate of 5%. And you are what will be its maturity value. Now let us have a look at how it works. So what you have done is you have invested rupees 1,000 at the beginning of the year. Now this, and you will withdraw your money at the 5th year. So from today, if you invest the money, it remains with the bank for 1 year, 2 years, 3 years, 4 years, and 5 years. It means for the first installment, the compounding should take place for 5 years. Then for the second one, for the second year, for the second installment that you pay at the beginning of first year, it will remain with the bank for a period of 4 years. 1, 2, 3, and 4 years. So that's why the compounding has been done for 4 years. The same goes 3, 2, and 1. Now for this also there has been a for. Now the main thing is because we are paying installments at the beginning of the year, what is happening is the compounding is taking place at one extra time for each of the installment. That is, it is happening for 5 times instead of 4 times. So what we do, the formula says annuity due. Now, whenever annuity due, as I said, it is beginning of the year. This is the formula for it. This entire square bracket formula is same as for the annuity. Only one thing changes. As I said, you have to compound it one extra time and hence we multiply the entire value with one more extra time. As you have seen in this case, we are compounding it one more extra time than the previous annuities. So that's why this one extra compounding is to be done. If you substitute all the values, you will get this particular answer. Now, if you see, because once the compounding has been done one extra time, here the return is 5,025, whereas the return in this case is 5,801, which is much higher. So this is about annuity due. These are the various sites or books that I might have used during making this presentation. Thanks to them. I thank all of you. uh, in my next lecture, I will be dealing with the present value. If you have found this lecture useful, kindly subscribe to my YouTube channel and press the bell icon to receive latest updates about the educational videos. Thank you once again.